Well, now that I know how much you're enjoying your trig functions, the last part of your assignment is going to have some matching problems like this one I have written up here. You have to find which one on the left, which numbered item, matches with a letter on the right by using your trig identities to show that one of them equals the other. Okay, so you can pick any one you like and try to simplify it down to equal the one on the opposite side. My recommendation to you is pick one that's messy and try to make it simple. It's very difficult to take one that is simple and try to make it messier. So what one do you see up there that looks at least somewhat messy? Well, I'm going to suggest we start with one that's not too bad. So I'm going to suggest we start with number 4 and see what we can do with number 4. You will hopefully notice that you have a sine of x times a secant of x times a cotangent of x. That's 3 different trig functions. So since you have 3 different trig functions, the best thing you can do is to change everything to sine and cosine in hopes that something will cancel. Okay, sine of x is already a sine. Don't change it. There is no law that says you have to change every term. That one's happy. It's in sine and cosine land. Secant of x needs to change. Well, by number 2, we know secant is 1 over cosine. And then last but not least, cotangent. Cotangent is one of those that has 2 different identities. Cotangent is number 3 or number 5. 3 says it's 1 over tangent. 5 says it's cosine over sine. In our case, which one is more appropriate? One that has tangent in it or one that has sine and cosine in it? Well, hopefully you said sine and cosine. So yes, we want to use the identity that says this is cosine of x over sine of x. Now do the algebra. What can you perhaps cancel? And yeah, that's the good news. Cosines go. You can cancel sines then, and you are left with a nice round 1. And so we know it matches with letter A up in the top right corner. All right, pick something else that looks messy. Usually they vote for D, so we'll do that one next. If I want to do letter D, whoa, this squares. But I have sine squared times cosine squared. Identities 6, 7, and 8 only have the terms added. They do not allow you to have the terms multiplied. So right now, 6, 7, and 8 aren't an option. They may become an option as we get this worked on. So if I can't do that, the only thing else I can do is change it all to sines and cosines. Once again, this sine squared is already a sine. Don't change it to something else. Cotangent squared, on the other hand. Cotangent we just used in the previous problem. We can see it's cosine over sine. Since it's squared, remember, the first 5 identities, you can put any power you want on them. So I'm going to make that cosine squared over sine squared. And of course, you notice the sine squareds cancel. Okay. So all we have left right there on the left is a cosine squared. Now I have a secant times a cosine. Once again, change it to sines and cosines. I'm going to change secant into 1 over cosine. I'm going to leave cosine alone because I like it. And you'll notice the cosines cancel. So what's left in that whole mess? Well, on the left side of the plus sign, there was x squared, and then we have a plus 1 left. Is that a match? And yes, it is. D matches with letter 2 up here. Okay, now, that was the 2 biggest, messiest ones. What else looks kind of messy to you? Okay, and I'm seeing some 3s, so let's go with 3. It's not real messy, but there's a little you can do to it. It's not squared, so we're not talking 6, 7, and 8. So we're talking the first 5. What can I do to a tangent to get it to become a sine or a cosine? Well, yep, number 4. Tangent is sine over cosine. And that the whole thing is all divided by sine. So now, What do I do when I have a fraction divided by a fraction? I multiply by the reciprocal. So I would have sine x over cosine x times 1 over sine of x. Cancel out my sines, and I am left with 1 over cosine. So yes, you have, have you improved, or have you found a match? I don't see 1 over cosine over there on the right-hand side. We know we've used up D and A, but I must not be done yet. Well, what else do I know about 1 over cosine? I know some of you out there hollering it, yes, by number 2, it's a secant of x. So therefore, I can say, oh, letter C must be the one I match to. Okay, notice, you could have done the opposite. You could have come over here to secant and said, oh, secant's 1 over cosine, and then said that matches. You are allowed to change things on both sides of equal sign if you need to. There's not a law that says you have to do one side or the other. Okay, and I know you all are going, well, hey, then the last one must match with B, but I want you to prove it to me. So I agree, it matches with B, but why does it match with B? There's not much to do. You got a cosecant squared x minus 1, and you got a cosine squared over sine squared. Well, somebody's saying, but cosine over sine, that's cotangent. So we actually make it cotangent squared. I can buy that. But how do I get it? What's I got to do with cosecant squared minus 1? Okay, that's something squared. It's added or subtracted, particularly with a 1 in it. That should scream at you, hey, dude, I'm number 6, 7, or 8. Slightly rearranged. We need that to be cosecant squared minus 1. We know from number 8 that 1 plus cotangent squared x equals cosecant squared x. And so I need to rearrange this to say cosecant squared minus 1. So I'm simply going to subtract the 1 to the other side, and I'll have cotangent squared is equal to cosecant squared x minus 1. And now that proves that the two of them are actually matching, because they're now both equal to cotangent squared. Okay, I know you'll have great fun with this, but I'll give you a word of caution. This takes some practice, so procrastination is not recommended. Have a good weekend.